opportunities for data encoding in Filecoin. Again, that's me, Rob McGinnis. There's a lot more past work, but relevant past work includes EtherStore. It was a distributed storage solution that utilized the front office workstations and organizations to essentially provide an alternative for on-site NAS storage or a secondary target. So you add up all the spare storage space, all the spare hard drive space across a number of front office workstations, and it looks and acts and walks and talks just like a regular drive, except it's obviously slightly more complicated than that. And then Moostar, which is really the project that requires the most data storage right now. We're using roadside cameras to detect infrared cameras, so it works day and night, to detect large wildlife on the road, and then alert drivers in real time using flashy lights. Reason being, I moved from New York out to Wyoming about 2 years ago, and we are blessed. We're surrounded by very large, very cool animals, but we see some moose hit on the side of the road, a couple times a year, and far more deer than that. And trying to come up with a solution that is portable and that is helpful for both drivers and wildlife was something I was happy to be able to work on here. So we'll see the rig for that in just a second. This is less interesting, I think. This is EtherStore. 3 tiers of local, an in-organization, and then web-based version backup. So it was like read through, write through caching with all sorts of things all chopped up in interesting ways. But the Moostar stuff is what I find most interesting right now. Moose, obviously, you can tell. We're using a FLIR. We got a FLIR camera and a couple of other brands that we're testing out. And this is the trailer that has just arrived. A bunch of community organizations got together and we gathered some funding to purchase a solar trailer. And you can see the really tall mast there that you mount the camera to. And information comes down to my little neural network in here. We snap a single frame. It takes about 1.5 seconds to process each frame right now. It'd be nice if it were faster, but that's to be worked on. And then you can see these yellow lights here that aren't hooked up to anything yet that will be alerting drivers that there is presently a large animal in the middle of the road or on the side of the road, and they ought to slow down. But it's not just one of those dumb, flashy animal beware lights. It's a right now kind of thing. So how is this relevant to what we're doing with Filecoin? Well, there is a ton of data that we need to store for Moostar, more data than I have the local storage for here, and I've got just a ton of stuff out in the garage. And of course, that's not resilient. It's local storage. I'm right at the floodplain here, so who knows, bad things can happen. And we want to make sure that all the data that we collect is stored in perpetuity and available, ideally, for anybody to access worldwide. So how do we do that? Well, we use Filecoin, obviously, but there are some challenges with simple replication. So say you want to store a large data set and you chop it into, say, 40 slices or so. Let's say you do 2 times replication. If you lose the wrong 2 copies of that file, you're out of luck. You're basically, you do no longer have the ability to recover that file. That's very frustrating. And you want things to last for a very long time, you just need to look at this. We're storing stuff on a bunch of different people's systems all over the world, and the annualized disk failure rate adds up to about 50% within 5 years. All of these columns add up, right? That means half of all hard disks fail within 5 years, which means that if we're using, non-professional individuals to store stuff, which is it's likely now, things will change. There'll be better best practices and stuff shared out, but it's very real. It's a very real possibility that within 5 years, 2 of those copies of data that will be required for your entire file to be accessible may no longer be accessible, right? So the quick comparison of basic replication using multiple copies of the same data, errors are detectable. You can't get the files, but they're not recoverable. The alternative is data encoding. Now it takes some extra data, you generate some extra data up front, and you store that together with your original file. And that enables you to both detect and recover from errors. So some example types I'm not going to get into are like Reed-Solomon encoding, Hamming codes, BCH, etc. I've got my contact details at the end of the presentation. You can get in touch with me on Slack if you want to learn any more. The brief example here, just for comparison of the math, a 40-part file using 2-time replication, you got to store 80 parts. You can lose only 2 of those, the wrong 2, and the file is completely unrecoverable. Now with really, really meaty, like usually you don't need to do it this much, but really meaty data encoding, you can store the same number, 80 parts, but as long as you can retrieve any 40 of those parts, you're good to go. So you can literally lose half of all of it. It doesn't matter which 40 you pick. You get 40 of them, you're good to go. So that helps in a number of different ways. First of all, obviously recovery, but imagine one of those replicas is out on, the slowest local internet connection you can find. My download speed's great here in Wyoming, but our uploads are capped at, way, way, way lower than the normal, 10%. It's like down at 1%. So coming down is easy, but going back up is challenging. Once you're done reading 40 of those parts, you're good to go, right? It's not free though. So there are upfront costs. So the time you've got to pre-process the data, and there's space. You have to have twice the amount of space on your available beforehand if you want to encode things this way. If you're doing just replication, you only need the exact size of the file. If you're going to pre-encode it, you need double the size. You don't always have to do it double. It could be a little bit less, but generally speaking, for this comparison with the 2x replication, you need twice as much space. So that could be challenging. Finally, upon retrieval, the client needs to post-process the data a little bit. And this can be, a little bit challenging. Sorry, not challenging, easy to do, but it takes a little bit of time. And of the order of minutes, though, for a few gigabytes and things like that, it's basically straight line. So it's linear to the size of the file. And so again, nothing's free. There are pros and cons to everything, but yeah, that's how we are planning to store the Moostar data, and we plan to get some of this code out there so that other people can take a look at it and maybe utilize some of these pre and post processing approaches in order to make their data more resilient in the network. Feel free to contact me on Slack at Rob Mack.